This video is part of the Airline History Museum at Kansas City's collection. This not-for-profit exists to celebrate the rich history of propeller-driven commercial aviation in this country. Based at Kansas City's historic downtown airport, the group began in 1986 when a group of aviation enthusiasts wondered whatever became of the Lockheed Constellation. Their efforts to find and then preserve one under the name Save a Connie became legend. We invite you to join the organization by calling 1-800-513-9484 between 10 and 3 Monday through Friday, or check us out on the web at www.airlinehistorymuseum.com.
Here is a site you may not have seen before and wouldn't be seeing now, but for the wild idea a couple of retired military flyers had about a dozen years ago. Larry Brown and Dick McMahon were talking one day and found that they agreed on one thing, that the Lockheed Constellation was the most beautiful, big propeller-driven hauler of people and cargo ever to soar up into the air. What they ought to do, the two men thought, was save one, so that a great era of aviation, the era between the airboats of the 20s and 30s and the jets of the 60s and 70s, would not be lost forever. Brown and McMahon were joined by hundreds of other love-struck volunteers who established what you might think of as a program to save the whales of the air. So it is that up above Kansas City,
feels wonderful,
folks can see a glorious reminder of how things were back when we were pulled through the air instead of pushed. One of the fellows who is privileged sometimes to sit at the controls of that wonderful super constellation started flying in 1936. He's 80 years old. They built airplanes to last once upon a time, and pilots too.
7 from cockpit. We've been cleared for takeoff.
This program is brought to you by the Airline History Museum at Kansas City. During the show, you will see our phone number and our website address across the bottom of the screen. We invite you to join us in preserving the history of propeller-driven commercial aviation.
This is the military transport version of the Lockheed Super Constellation. Specifically modified and equipped to meet military requirements, it is quickly convertible from cargo plane to personnel passenger plane or to a giant air ambulance filled with litters for the sick and wounded. Designed to fly faster, farther, and offer more economy per ton mile than any available cargo airplane, the aircraft is capable of flying fully loaded from coast to coast in less than 8½ hours. On reaching its destination, it is readily convertible without structural modification to any one of its configurations. When used as an overland passenger airplane, it carries a crew of 4 and accommodates 106 passengers. Used as an overwater passenger airplane, it carries a crew of 8 and 97 passengers. As an overland evacuation transport, it carries a crew of 8, including 4 attendants. Litters are installed to accommodate 73 litter evacuees. In the overwater evacuation configuration, it carries a crew of 12, which includes 4 attendants and 67 litter evacuees. When converted to an overwater cargo airplane, it carries a crew of 8 and 33,300 pounds of cargo. In overland cargo versions, the crew is reduced to 4, and the payload is increased to 34,600 pounds. In overload conditions, the payload increases to 39,500 pounds. The construction and sealing of the fuselage and its doors and openings permits sea level pressure to be maintained in the crew, passenger, and cargo compartments at all altitudes up to 12,300 feet. Even at 20,000 feet, the pressure altitude within the cabin is only 5,000 feet. The main cargo compartment is 82 feet in length, and its maximum solid loading volume is 4,770 cubic feet. The lower forward cargo compartment provides a net volume of 269 cubic feet. The lower aft cargo compartment has a net volume of 424 cubic feet. The total maximum cargo volume for all compartments is, therefore, 5,463 cubic feet. The main cargo compartment has 2 doors on the left side of the fuselage for loading cargo, passengers, or litter patients. The wide main cargo door is opened by a hand-operated hydraulic pump. When the airplane is used in its passenger configuration, this cargo door is closed, and its integral personnel door is used for loading troops or passengers. The forward cargo door is also hydraulically operated. An emergency exit door is opened quickly by a downward and inboard pull on a single handle. The forward lower cargo compartment has 2 access doors, one in the rear bulkhead of the nose wheel well, which slides up and aft on tracks into the upper portion of the compartment, and a second door located in the bottom of the fuselage. The lower aft cargo compartment has 1 access door, also in the bottom of the fuselage. To prepare the airplane for passenger service, it is first necessary to send to storage or stow in the airplane any litter or cargo provisions not necessary in the passenger configuration. Next, the cabin should be thoroughly cleaned and all dirt removed from the various floor fittings prior to the installation of any passenger equipment. When the cabin has been cleaned, the indicated emergency equipment, such as life rafts, is installed and checked against a specified list. The comfort provisions required for a passenger transport configuration include installation of the galley on the left or port side and the food storage unit on the right or starboard side. These units are secured by quick-release fasteners. This is accomplished rapidly through an installation procedure described in the Handbook of Cargo Loading Instructions. The lightweight centerline partition divides the lavatory into 2 equal sections and supports various items necessary to the lavatory. Overhead cabin baggage nets are installed and window curtains secured. The passenger seats are cushioned with air foam rubber and equipped with a recline mechanism. This new type slip-on headrest is a Navy development, adding to passenger safety and comfort. Also, a new seat belt incorporates several outstanding features, including single motion, fastening, and release action. 23 double chair units are installed on the port side of the airplane, and the 20 triple seat assemblies on the starboard side. For greater passenger safety, the seats face aft, unless loading instructions specifically state otherwise. Chairs and floor fittings have been designed so that the seats also may be installed facing forward. The outer legs are adjustable to fit any location in the cabin and provide for aft or forward-facing positions. Seat removal is rapid and simple. The backrest is placed in an upright position, and the trigger release allows the backrest to be folded onto the seat cushion. It is automatically locked in the down position. The locking rings are then raised, and the seat legs are disengaged from the floor studs. Leg braces are disconnected, folded, and secured with bungee cords to make the seat assembly an easily handled package. At the forward section on the starboard side, the relief crew seat bunk is arranged to seat 4 members side by side. Opposite this is a removable toilet. Without modification, the relief crew seat is easily converted to an upper and lower bunk. A partition separates the crew bunk from the first row of passenger seats when the airplane is in the overwater passenger configuration. This partition is quickly removable. To convert to an evacuation transport, the seats, if installed, are removed and can be stowed in the lower cargo compartments or stored at shore facilities. Litter transport comfort provisions are completed by the installation of the lavatory and galley equipment, if not already in place. A watertight, corrosion-resistant steel cabinet is secured to provide storage for 6 bedpans. These are the sidewall litter supports. The litter stanchion assemblies, which support and secure the port side of the center tier of litters, are put up. Each litter strap assembly, which is the adjustable support necessary to secure the inboard side of the wall litters and the starboard side of the center litters, is installed, and the litters are secured to this support equipment. A portable litter lift may be attached at the main cargo door, and its action controlled from an extension cable. This equipment will on or offload 2 litter evacuees. It may also be used to load miscellaneous cargo up to 500 pounds. In the litter transport configuration, if it is necessary to carry all the personnel, litter, and cargo equipment with the aircraft, 17 triple unit passenger seat assemblies are stowed in the forward lower cargo compartment and 18 double seats and 1 triple seat unit in the forward portion of the aft cargo compartment. The aft section also provides space for passenger baggage, excess life jackets, exposure suits, and cargo handling equipment. The special equipment designed for either personnel or litter provisions must be accounted for in any conversion to a cargo transport. The exact nature of the cargo operation or mission will dictate which items need to be removed, stowed aboard, or left installed. To permit rapid, easy loading of large cargo items, the main cargo door opening is 112 1/2 inches wide and 74 1/2 inches high. The forward cargo door opening has a clear width of 61 1/2 inches and is 72 inches high. The flooring in the main cargo compartment, from the aft cargo door to the pilot's compartment, is constructed of removable sections of extruded magnesium. This unique design feature gives the airplane a cargo flooring of unprecedented strength. The allowable cargo load in the main cabin loading area is 1,000 pounds per running foot, or 300 pounds per distributed square foot. In concentrated loads applied through the use of skids, machine legs, or wheels, loads up to 400 pounds per square inch may be applied without floor damage, provided a load limit of 1,500 pounds per floor beam is observed. These beams are readily located since wall fittings mark the location of every other beam. To speed loading operations, a cargo conveyor system is planned as future standard equipment in all R7V1 C-121C airplanes. A portable power unit houses a drive shaft and motor which draws power from the aircraft. The spline drive shaft drops into the sprocket housing, which also provides for securing bolts. The endless chain can be made to move in either direction in the extruded track, which extends the entire length of the cargo compartment. This special fitting, called the mouse, drops in to engage with the chain and travels with it below the floor surface. This provides a hold for the accessory attachment called the donkey and is used to push or pull cargo along the floor. By securing a rope around the cargo as near the floor line as possible and passing the rope loop over the head and neck of the donkey fitting, cargo can be pulled forward or aft. The conveyor chain speed with full loads is 20 feet per minute. The conveyor will move a maximum dead weight of 4,000 pounds, but if the load is skid mounted, it will move up to 8,000 pounds. And if the load is on wheel dollies, the conveyor will safely handle up to 12,000 pounds. The movement of the conveyor is controlled by means of a hand switch attached to a rubber-covered electrical cable stored on a spring-loaded reel for starting the conveyor in either direction or to stop it. A permanent pulley is installed in the floor opposite each cargo door to change the direction of pull and aid in moving cargo into the aircraft. The cargo lever dolly is used here as a guiding device. Several portable pulley blocks are supplied with the aircraft. An adapter is located below the pulley frame which fits into any floor seat fitting. These quickly positioned pulley blocks change the direction of pull for moving cargo out of stowed locations. Two light cargo dollies equipped with roller-bearing wheels are supplied with each airplane. The wheels are spaced to ride freely in the extruded channels of the floor. This airplane can be rapidly and conveniently loaded through the use of the Lockheed-designed Aerolift, a mobile air-transportable cargo elevator which provides 100 square feet of useful platform. The Aerolift can raise loads up to 13,000 pounds to a height of 144 inches in 1 1/2 minutes. The platform is activated by an electric hoisting winch and cable drum, which draws its power from the airplane's electrical system with auxiliary power plant or from any suitable 28-volt ground power supply. Controlled by a switch on the end of a long retractable cable, the Aerolift can be operated from the ground, from the platform, or from inside the airplane. An inboard ramp bridges the gap between the airplane and the platform when the aerolift is in the raised position, and the outboard ramp provides for uneven ground surfaces when the platform is lowered. Heavy cargo can be pulled out of the cabin by fitting portable pulleys on the aerolift platform and using the airplane's conveyor power. To facilitate direct unloading from aerolift to truck, the platform may be stopped at any intermediate position. In this instance, the truck's power winch is used to remove the cargo. Retractable wheels permit easy towing over unpaved or paved airfields. The aerolift components can be stowed in the lower cargo compartments for shipment to advanced bases or remote airfields. There are a variety of forklift trucks which can load the aircraft. Those used, however, must have a lift of at least 8½ feet for the main cargo door and 11½ feet for the forward door. Package size limit charts furnished with the airplane provide a simple method of determining the relative dimensions of cargo which may be loaded through a specific entrance. Air cargo is subjected to dynamic forces during flight, landing, and takeoff, and tie-down devices must be secured to oppose these forces. To restrain the forward longitudinal force, the angle between the floor and the tie-down device should be kept within 40 degrees. It is recommended that miscellaneous low-density cargo be restrained by the use of nets, and that high-density cargo be broken into smaller groups or individually tied down. Tie-downs fastened at angles to the cargo serve to restrain one or more directional forces. The amount of restraint available depends upon the strength of the tie-down device and the overall capacity of the airplane's tie-down fitting. The amount of restraint needed must not exceed the capacity of the floor or wall fitting. However, the angle of pull-off does not limit the 4,000-pound rated capacity of the R7V1 C121C floor fittings. Type A1A tie-down devices supplied with this airplane have an ultimate tensile strength of 1,250 pounds. Tension is applied on the webbing that passes through the quick-release fastener. This buckle cam grips the strap as it tightens and automatically holds the strap in the desired position. To release, press down on the cam. Side plates protect the cam from accidental release. Cargo tie-down nets, made of manila rope, are approximately 100 inches square. The rope has a tensile strength of 1,350 pounds. Extreme flexibility makes these nets useful to secure cargo up to a capacity of 6,000 pounds per distributed load. By means of the slide rule computer, designed especially for the airplane, the proper application of weight and balance data is determined for the safe and efficient operation of the aircraft. In any configuration, the R7V1 C121C provides assured comfort for its crew, passengers, or litter evacuees, and protection of cargo through the air conditioning system, which delivers pressurization, auxiliary ventilation, heating, and cooling. The airplane is now in wide use throughout the military air services, proving its versatility as a quickly convertible, flying freighter, ambulance plane, or high-priority mission personnel transport. A Lockheed contribution to the continued efficiency of the military air services.
We hope you've enjoyed this look back at aviation history. We invite you to join the Airline History Museum at Kansas City by calling 1-800-513-9484 between 10 and 3, or look us up on the web at www.airlinehistorymuseum.com. Membership does have its privileges. How else are you going to get to ride in something like that? Call 1-800-513-9484 to join. Special thanks to the Lockheed Martin Corporation. And special thanks to the Atkins family for the following footage of Kansas City's Municipal Airport, 1958.